Hey guys, welcome back. Sorry about that. The last video got cut off. So we're going to continue back onto question 2. Okay, so the points listed in the table below lie on the parabola. X equals to negative 2, y equals to negative 6, x equals to negative 1, y equals 0, x equals to 3, y equals to 4, and x equals to 5, y equals to negative 6. Sketch the parabola represented by these points and give the coordinates of the x-intercept and vertex. Okay, so basically, so as you can see, when x equals to negative 2, y equals to 6, okay? And when x equals to negative 1, y equals 0. So in between these two x values, there's a plus 1. And in between these two values, these two y values, there was a plus 6. Okay? And if we look back here, point number 5. So if we, it's negative 6, okay? So we move this back by 3. So this is plus 6 to move from up to down. If we move down to up, will be negative 6 or minus 6. This will be we'll do somewhere else. So we have our 5, 5, negative 6. Okay, so we're gonna move this back by we're gonna add 6 onto our negative 6. Okay. Yeah, we're gonna add 6 onto our negative 6, and then our 5. Okay. So our 5, we're gonna take away 1 from our 5, okay? Okay, so if we reverse these steps, we'll get 4. We can do this because our parabola is symmetrical, okay? Because our parabola is symmetrical, it's the same on both sides, okay? So if we have our 5, okay, we take away 1, and we have our 6, okay? We're gonna add 6 onto our negative 6, okay? So this will give us 4, 0, okay? And so when x equals to 4, y equals to 0. So therefore, when we have when x equals to negative 1, y equals to 0. So therefore, we have both our x-intercepts. So both our x-intercepts are we have one at negative 4. No, we do not have one at negative 4. We have one at negative 1, and we have one at 4. Okay. So basically, okay, we have our negative 2. So basically, if we look above, we have our negative 2, negative 6. Okay, so negative 2, negative 6 here. We have when x equals to 3, y equals to 4. Okay, and we have when x equals to 5, y equals to negative 6 back here. So we're gonna roughly sketch out this parabola. Okay, so it should look something like this. Sorry, it's not a very good drawing, but it's a terrible drawing. Okay, so it should look something like this. Okay, so basically, it wants you to identify the x-intercepts. Our x-intercepts are negative 1 and negative not negative 1. Where our x-intercepts are negative 1 and 4. So simply say our x-intercepts. So our x-intercepts. Okay, that's. We have one at 0, not 0, negative 1, 0. And we have one at, and we have an x-intercept at 4, 0. And we have our vertex. Okay, so what is our vertex? So our vertex occurs at the midpoint of our x-intercepts. So the midpoint can be calculated by adding these two together and dividing by 2. So 4 plus negative 1 divided by 2 becomes 3 divided by 2 equals to 1.5, okay? So when x equals to 1.5, okay, what is our y value? That's basically asking us this, okay? First, we need to find the equation of our graph, okay? So basically, we have our y equals to a. Our x-intercepts are negative 1 and 4, so x plus 1. Double negative makes a positive, and x minus 4. We're going to substitute one random point, okay? We're going to substitute 5, negative 6. So negative 6 equals to a. 5 plus 1. 5 minus 4. Negative 6 equals to a. 6 and 1. Therefore our a equals to negative 1. So therefore our equation is y equals to negative of x plus 1, x minus 4. So now we substitute our midpoint, which is x equals to 1.5. So we say y equals to negative 1.5 plus 1, 1.5 minus 4. And that should give you y equals to 6.25. Therefore, our vertex, works out to be 1.5 dash 6.25. Okay, that's our vertex. Okay, and getting all the way to the correct vertex and the correct intercept and the correctly drawn graph will get you an excellence grade. To get you a merit grade, okay, so you're giving the correct x-intercept and the correct vertex, okay? So the correct x-intercept and the correct vertex will give you a merit grade. To get an achieved grade, okay, you're getting the so you can have so you have the intercepts and the vertex, okay? But for your x-intercept and vertex, okay, you can have so any two. So basically you can have for example negative 1 and 0 and 1.5 and 6.25, or you can have negative 1 0 and 4 0. Okay, so any two will get you an achieve basically. Okay, moving on. Give the equation of the graph. Okay, we already found our equation of the graph. Okay, so simply state that y equals to negative x plus 1 x minus 4, and this here will get you a merit grade. Okay, moving on. Question 3. Give the equation of the graph below. Okay, so as you can see, our equation for our exponential is y equals to a to the power of x minus b plus c. Okay, so as you can see, our exponential gets closer and closer to 0. Okay, so therefore our c value is 0, so we can just get rid of that. So therefore y equals to a to the power of x minus b. Okay, so but as you can see, this graph, okay, it has 0.5. Oh no, 0.5. Yeah, it is 0.5, and then we have 1 1, and then we have 2 2 2, and then we have 3 4, and then we have 4 8. As you can see, as the x value increases by 1, our y value doubles. Okay, and because it doubles, we can assume that our base is 2. So for example, 2 to the power of 1 is 2, 2 to the power of 2 is 4, that's double of 2, 2 to the power of 3 is 8, 8 is double of 4, 2 to the power of 4 is 16, 16 is double of 8. So we know that our a value is 2. So y equals to 2 to the power of x minus 2 to the power of x minus b. Okay, so in order to find our b value, okay, we're going to be seeing how much it's been shifted left or right. Okay, so basically normally y equals to a to the power of x as our non-shifted. So if we non-shifted, okay, so if our non-shifted, so it'll be 2 to the power of 2 to y equals to 2 to the power of 0. Sorry, I'm going too fast. If we substitute x equals to 0, so we're going to say that y equals to 2 to the power of 0. That should give us y equals to 1. But in this case, okay, when x equals to 0, we get 0.5. And when y equals to, when x equals to 1, our y equals to 1. Okay, so basically our graph has been shifted 1 to the right, because our y equals to 1 value occurs 1 unit right than what it should be. Therefore, our whole graph has been shifted right. Okay, so therefore, because it's been shifted right, okay, our b value is 1, and therefore we'll say that y equals to 2 to the power of x minus 1. Okay, and that's our final equation for the exponential, and that will get us a merit grade. Okay. Get the equation of the resulting graph if the graph is above is reflected in the y-axis. So if it's reflected in the y-axis, we make x negative. Negative x, okay? So therefore, our y is simply becomes y equals to 2 to the power of negative x minus 1. And this here will get you an excellence grade. So y equals to 2 to the power of negative x minus 1. Excellence grade here. Okay? Next question. A new fun park was very popular when it opened. In the first 3 months, an average of 4,000 people visited in the park each month. After the first 3 months, the attendance began to drop approximately 15% each month after the next 9 months. After the first 3 months, the approximate number of visitors to a park can be modeled by p equals to 4,000 times 0.85 to the power of n minus 3, when n is the number of months since the park opened. Complete the table below showing the approximate number of people who visited the fun park during each month of the first year. So basically, okay, so in this question, okay, we're simply just going to substitute, for example, for month 1, we'll substitute n equals to 1 in this equation. For month 2, we'll substitute n equals to 2. For month number 3, we'll substitute n equals to 3, and so on. So just be plugging this into a calculator, okay? So, but it does tell you, okay, it tells you that in the first 3 months, an average of 4,000 people visit the park each month. So say that for the first 3 months, okay, it's 4,000 people per month, and then it began to drop. Okay, so now we substitute n equals to 4, then we substitute n equals to 5, then we'll substitute n equals to 5. Okay, and you should be getting that 3,400 here. It should be getting 2,890 here. Alright, and getting the correct table will get you a merit grade, actually. Okay, and to get an achieved grade in this question, you have 2 correct months. Okay, draw the graph of the appropriate number of people visiting the fun park each month. Okay, so we're gonna start off the first 3 months. Okay, the first 3 months we start at 4,000. First 3 months stay constant at 4,000. Okay, then it will be dropping down to then it drops down to 3,400, so it should be 3,400. 3,400 should be here. Then it drops to 2,890. Okay, should be around here. Then it drops to 2,457. Then 2,088, 2,457. So 2,457. Oh gosh. Then it drops to then it will drop to 2,088. Then drops to 1,775. Somewhere there. Then it drops to 1,509. Somewhere here. Okay, so then it will be dropping to 1,282. Then drops to 1,090. And then finally it drops down to 926. Okay, so now all you have to do is connect the dots together, okay? So the first 3 months, okay, you have a straight line here for the first 3 months. Okay, it's not very straight, but you know my point, okay? You'll have a ruler in the exam. So now just draw your graph, okay, looks like an exponential shape. Okay? So as you can see here, drawing the correct graph here will get you the merit grade. To get an achieved grade, you have at least 5 points correct. Okay, moving on. At the end of the month, that the number of visitors dropped below 2,000 for the first time, the management decided to only open on weekends. Find how many months of the year the park was opened only on weekends, and explain by using features of the graph how this information can be found. Okay, so basically, okay, we'll say that first we need to find we have our equation. It tells us our equation is p equals to 4,000 times 0.85 to the power of n minus 3. So we have our p equals to 0.85 4,000 times 0.85, sorry, I forgot. 4,000 times 0.85 to the power of to the power of 0.85 to the power of n minus 3. So how long will it take for the visitors to drop below 2,000? Okay, so we'll make the number of visitors 2,000. That's our p-value. We'll make that equal to 2,000. Okay, so we move the 4,000 to the other side. Okay, so we'll say that how am I gonna do this? 0.5 is equal to 0.85 and minus 3. I don't know how to do this without using logs. So therefore, okay, I know our way. So let n minus 3 be x. Okay, so 0.5 equals to 0.85 to the power of x. Okay, so therefore we can say that we'll say this does not work to how I want it to work. Okay, no, let's not do this. Okay, so basically, okay, we're going to take the logs of both sides. Okay, we're going to say log of 0.5 equals to, you take the power down, okay, so n minus 3, log of the base, okay, so log of 0.85. And then you should have this on your calculator, okay, so just put log of 0.5, move the log 0.85 to the other side, so log 0.5 divided by log of 0.85 equals to n minus 3. Okay, therefore, you should get that 4.26 equals to n minus 3, n equals to 7.26, okay? So therefore, you can say that at the end of 8th month, there is less than 2,000 visitors. Okay, so basically for the log question, you take the log of both sides, okay, so that's log of the left side, okay, and the log of the right side, okay. So basically, the power, so this is 0.85 to a power of n minus 3. The power comes down, okay, so power comes down, and then you log of your base. So then you do log of 0.85, which is your base, okay. Then you move the two logs together, you divide, and then you calculate the numerical values, okay. Basically, that's it. Getting the correct answer here will get you the merit grade, okay? And to get an achieved grade, okay, so you have a partial description, okay? So, so basically like a correct guess or like a inaccurate answer might get you an achieved grade, okay? In the second year, more people visit the park during the first 3 months. As the year progresses, the number of people visiting the parks declines at the same rate as it did for the first year. The managers want to limit a maximum of 2 months, the period when the park is running on just weekends. What is the average number of people who will need to be visiting the park each month in the first 3 months for this to be achieved? Okay, so you have your P equals to 4,000, not 4,000, sorry. Now we have our P equals to an unknown value. We'll call it X, okay, so, not X, is bad. We'll call it, M times of, 0.85 to the power of n minus 3. So this time, okay, so this time is basically, we have our visitors to be 2,000 once again, okay. So, how long will it take for the unknown value of people at the start? Unknown value of people is the M. Okay, so the managers want to limit to a maximum of 2 months. The period of the park is running on just weekends. So the managers want there to be a total of 10 months, okay? So a total of 10 months to be more than 2,000, okay? So therefore, we can substitute our n equals to 10 months, okay? So for 10 months, we want to have more than 2,000 people, okay? So m times 0.85 to the power of 10 minus 3 is 7, okay? So therefore, 2,000 divided by 0.87 to the power, 0.85 to the power of 7, okay? So basically, I'll explain one more time, okay? So our m, the m we have here, That's the unknown amount of people visiting the park initially. So we're trying to find how much people is going to be visiting the park initially. We're substituting P equals to 2,000, okay? That's because the managers are running the park on just weekends when the number of visitors drop below 2,000, okay? So when the number of visitors drop below 2,000, then the managers will open it on weekends only. But and then it tells us that the managers only want to limit this to 2 months. So therefore, the managers want there to be 10 months when there is more than 2,000 people visiting the park, okay? So therefore, we can substitute our P equals to 2,000 and our time equals to 10 months, okay? So basically, now we have our 2,000 divided by 0.85 to the power of 7, and that should give you, our M value should be given as 6,238.7. That rounds up to 6,239. Therefore, there needs to be 6,239 people at the start. Okay, then that's your final answer here. Okay, and that's to get you the excellence grade here. So to get a merit grade, okay, so you get a merit grade, you only have the 6,238.7, and you didn't round it to 6,239, you'll get a merit grade. And getting an achieved grade is not available grade for this question. I'll explain one last time, okay? So we have our P equals to our new number of people, okay? So we have a new number of people visiting the park, but we don't know what that number is, okay? Because the number has changed. It's not 4,000 anymore. Okay, so the managers want to limit a maximum of 2 months in the period of when the period is just running on just weekends, okay? So this means that it wants 10 months to be running on all days, okay? So therefore, the managers close off the park only when the number of people drop below 2,000. So therefore, we can substitute our P equals to 2,000 and our time is 10 months, okay? And then we solve the equation to find our starting number of people. Okay, and that should be it. Okay, so thank you for watching this walkthrough of the 2016 level 1 maths tables and equations walkthrough. I hope you enjoyed the video. Okay, if so, leave a like below. Okay, and I'll see you in the next one. Thank you. Bye.